How can AI generate new things it hasn't seen before? I'll explain the intuition behind a technique called autoencoders, then run through the full code to train one from scratch to generate new images. The best place to start for this is in my wardrobe. This isn't me just flexing. That's just a happy little accident. Give me 2 minutes to explain my wardrobe and you'll understand everything you need to know about embeddings, autoencoders, and generative AI. I am
an odd fellow,
so I arrange my wardrobe in a particular way. Things that go on my head go at the top of the wardrobe, and things that go on my feet go at the bottom. So hats at the top, shoes at the bottom. Coats are higher up than jeans, etc. Going left to right, I arrange it so that things are short to long. So short sleeve shirts are on the left, and long sleeve shirts are on the right. Trousers are on the right side, shorts are on the left side. Speedos even further left. With things arranged like this, I can say with certainty where any new item of clothing should go. And even more than that, I can infer what should go in certain spaces, even if I've never seen that thing before. For example, I don't own any gilets because I'm not a and imagine a world without gilets. If I wanted to know what's in this spot here, I can reason that it's similar to a coat, but it has no sleeves. Bingo bango, I've just invented the gilet. What we've made with this peculiar wardrobe is a two-dimensional embedding. This idea of embeddings is a powerful one, and it's used in different areas of machine learning. It's when we compress information about some complex entity into a lower dimensional vector. See this related video which uses embeddings in the completely different context of movie recommendations. We can think of my wardrobe like a graph. The x-axis is length, and the y-axis is body part. If we put some numbers on these axes, then I can describe a coat in two numbers, 4, 4. Then, to invent a gilet, I sampled from my embedding space to ask the question, what should be at the point 0, 4? In this case, we compress the information about clothing into just two numbers. This is the idea behind a type of generative model called an autoencoder. Let's look at an example of an autoencoder. The input of the model is a grayscale image of an item of clothing. It has 28 by 28 pixels, which means we use 784 numbers to describe it. The target output is that same exact image. But in between, we want to compress the information down into two numbers, and then expand it back up to something that's as close as possible to the original image. So the first half is encoding an image into an embedding of two numbers. The second half takes an embedding and expands it back up to an image. This is called the encoder, and this is the decoder. Think of them like two friends playing a game. The encoder looks at a picture and tries to describe it in 2 words. The decoder then draws a picture based on that description. The better the two of them are at this game, the closer their pictures will be. Then, once the decoder is really good at this game, I can pass him any two numbers and he'll create an image for me. As a pedantic practical aside, we could try to do this compression straight away in one step, but what tends to work better in practice is to gradually compress it in the encoder with some intermediate steps. Then the decoder does the opposite steps. This is the code to train an autoencoder, which is linked in the description. We're passing in images from the Fashion MNIST dataset. These are 28 by 28 grayscale images of different items of clothing. We create an encoder which compresses an image into 2 neurons. We create a decoder which reconstructs full-size images from just the 2D embedding. Then we stick them together and train it. Now we can pass some numbers to the decoder and generate new clothing images. Louis Vuitton, eat your heart out. Although we didn't use them to train our model, we do have the labels of the clothing category of each of our images. We can plot the embedding space and see the model did a good job of grouping similar items of clothing together. Even though all it had was the pixel values, it didn't know the labels. We can pass it a bunch of different numbers to sample from regular points in our embedding space. In other words, go through our wardrobe to see what clothes are in each location. That was everything you need to know about embeddings and autoencoders. Time to update your CV.